Hello guys, we'll talk about the local area network. LAN, an acronym for local area network, is a type of computer network which falls under the category of networks based on geographical coverage area. LANs typically occupy between 1 to 10 kilometers in range. They can also span across a group of buildings or even an entire campus, covering the wired and wireless networks to connect users, terminals, and other devices to facilitate resource sharing. Not all LANs, however, are this large in scale. In the real world, LANs are defined on the basis of the technology used or the transmission media, such as Wireless LAN based on the Wi-Fi technology, or Wired LAN, of which the most commonly used technology for its construction is Ethernet. Another important defining factor for a LAN is that it must have local administration. This means an on-site or remote administrator should have the access and authorization to operate and maintain the network. Taking these factors into consideration, let's see how Ethernet-based LANs have evolved over time in terms of network construction. A LAN can be as simple as just two computers connected together with a wired channel used to carry Ethernet traffic between them. In the early days, this wired medium was a coaxial cable offering no more than 10 megabits per second speed. Another interesting thing about Ethernet-based LANs is that it allowed for multiple end stations to share the same link by tapping from the existing connection. End stations connected this way are said to share the LAN segment or attached to a shared medium. As simple as it looks, it is difficult to set up as you need to split this cable and terminate all points on a BNC T connector each time a new connection is to be made. When cable ends are not properly terminated, this can cause signal reflections, which corrupts the useful network traffic. In addition, there is no data privacy as traffic is always flooded across the link, even for one-to-one communication. This flooding burdens the CPU resources of other hosts, as they have to always process and discard the unwanted traffic. Flooding of traffic also consumes the network bandwidth resources. There was also another prevalent problem. Full duplex communication was impossible, as collisions would occur whenever two end stations attempt to send traffic simultaneously. Hence, the carrier sent multiple access with collision detection was applied to manage collisions, but still, this wasn't enough, as end stations have to wait until the network becomes silent again before sending traffic. This network construction procedure also had very poor scalability and low fault tolerance. Fast track into the future. A device called a hub was developed. Hubs greatly simplified network construction, as each end station only needs to connect to a central device, which may have 4, 8, or 16 physical ports. These ports on the hub could offer a maximum of 100 megabits per second Ethernet speed. Although some hubs have additional BNC port to connect coaxial cables, the main data ports were RJ45, requiring the use of twisted pair cables terminated with an RJ45 connector. Connecting end stations in a hub, however, is similar to the earlier network construction method in terms of its traffic forwarding mechanism. A hub will repeat a signal received on an interface to all other interfaces, as it cannot forward unicast traffic to the required destination. Full duplex communication was also not supported, as all end stations connected to a hub belong to the same collision domain. Modern-day Ethernet LANs are constructed using a switch. Compared to a hub, a switch is far more intelligent and can forward unicast traffic by differentiating end stations using a unique identifier called a MAC address. They can also connect terminals to other LANs using twisted pair cables or optical fiber cables, offering speeds of up to 100 gigabits per second on a single port. More details on the working mechanism of a switch and the concept of a bridge LAN will be discussed in the next video. Please subscribe and share. Thank you for watching.